Hi, this is Martin, Customer Success Engineer at GitLab, and today I would like to share some notes on the recent project on adoption data reporting. The problem as follows was, as a customer, I need to report which GitLab features are used and how much, because I want to assess ROI of GitLab, I want to align usage between business units and teams, and generally, I want to know where to focus my adoption efforts on. As for the iteration 0, that's the general approach we are taking today. We do instance level metrics and share them with the customer. These are generated by service ping, and that generates instance level summary statistics and sends them to GitLab. That's over 2,000 individual metrics here. So for central use cases like SCM, CI, CD, secure, we have health scores that define which metrics to focus on and what is considered good. So our iteration 0 is we send those usage metrics to the customer as an export file. So we can see here, we can show usage over time, and we can find that there is, well, in this case, healthy adoption. For example, here, recently 73% of billable users are using the SCM functionality and 52% are using CI. This provides a pretty good approximation of ROI, right? I'm paying for so many seats and I'm happy to see that those users are using the features I'm paying for. Now, the pressing question is, where's the delta, right? Where are the users that are only using SCM but not CI? We'll address this later, but let's get ourselves out of the loop first, because this data is manually compiled by me. It's manually copied from internal systems into a spreadsheet template. So the customer is dependent on my action for reporting, and that does not scale. I don't like it. Let's continue to iterate and find a way to automate it. So fundamentally, the service ping data is generated on the instance, right? So we can pull that data from the instance and send it to some business intelligence tooling. So the admin settings provide access, but only via web login, not API. So we don't have an easy way to export this data from this path. This means we need to use Rails, right? On a GitLab node, we can execute this rake task, and then we can get this data transferred into a system where we can report on it. This is the architecture we came up with the customer. So there is Rails. We do a scheduled generation of the service ping JSON, uploaded to S3, and similarly scheduled, we fetch it via GitLab pipeline. We extract relevant metrics and normalize, and then we send it into an Excel file. That's a bit cumbersome to set up, right? Like cron jobs with Rails commands, uploading data, that's not an ideal workflow. And this the dependence on pipelines, files, and so on, it's not really compatible with existing BI systems. We need an API for this. So I went ahead and requested with the team of analytics instrumentation an API for service ping data. They delivered the service data API, or will deliver it in 16.9. That's going to be 15th February. And they only took 2 months for that. So amazing job. That enables us a much cleaner architecture with fewer dependencies. We just fetch the service ping with a tightly scoped admin token from the service ping API directly from our BI solution. This custom scoped API token makes it safe, even though it's an admin token. It can only read that service ping data. It can't do anything else. So what did we address, right? What did we achieve? The question was, I want to report on which GitLab features are used and how much, because I want to assess ROI. Okay, we can do this with the service ping data. But I also want to, align the usage, and I want to focus my adoption efforts, and instance level data is not enough for this. We need more granular data. That's answering the question we had earlier. Where are the users only using SCM but not CI? Which groups have little adoption? So let's get further in our iteration and do more granular usage data. Requirements as follows. I want summary statistics for each top level group. And that is for the start, merge requests, pipeline counts by status, and deployment counts. And because the service ping only provides instant statistics, we need to pull this data from the API. We are going to use the GraphQL API because it provides a larger amount of data per call and making it more efficient. And it also has a very handy count function that can count objects. Otherwise, we would have to iterate through pages and pages of objects to count them, which would take a very long time. We'll get the data on project level and then aggregate on group level to get our high level view. Looking at the GraphQL API, we can see that we can easily get projects for a group and then traverse to pipelines and merge requests. We can filter by dates to get monthly slices and pipeline status. So that's pretty nice. Let's do the same for deployments, right? Yeah, nah, that's unfortunately not a thing. It actually looks like this. So we need to traverse via environments. That's kind of bad because in the generic case, across thousands of projects, we don't know which environments are interesting. And there can be a lot of them, like review environments. And we can also not rely on projects using the environment tier, like production environment tier, to annotate the environments. And finally, the final blocker, we have this little star here, right? So for the project, the environments, we can only pull it for one project in any single request. So that basically disqualifies this query strategy at scale. That means it's going to be REST for the deployments. So first things first, we want to get data for a lot of groups. So we set up a service user and we invite the user to every top level group and we create a read API token. Alternative would be an admin token, which is dangerous, so we don't do it. We resolve the groups, the top level groups via REST. That's quick and avoids the nested pagination in GraphQL. And then for each group, we do our GraphQL query for pipeline and merge request counts. And for all the projects we get back, we count the deployments via REST. That is relatively efficient. So we only need like 17 minutes for the 3,700 projects in GitLab org. Most of the time spent to count deployments. Project is linked and you can just try it yourself as well or recommend to your customers. As for the results, they look pretty nice, right? We can build tree maps that show us the pipeline count per group. That is the box size, right? Here's the GitLab project. And we can also visualize the the percentage of successful pipelines using the color. So like just visually from a very high level, we can identify like low pipeline usage and potentially also flakiness with very low success percentages. And that is, just let this fly in here, right? It is of course interactive, so I can see what's going on here, right? Like so many pipelines, none of them successful. Like that may be something I want to focus on, right? And over here, that's interesting. There's a test group that does 20,000 pipelines. So that is also something interesting to look at. And similarly, for the merge request usage, we can also have a tree map that can show us the count of MRs, that is the box size. And here I put the color as the number of pipelines per MR, right? I'm not quite sure what that means. like lots of pipelines for MRs, I think would mean that it's more complex, right? But yeah, subject for debate. I think it may be an indicator of project complexity. So, what's next? Um, two uh, two parts to that, right? For the architecture, I think the API approach is fundamentally okay, but we need better built-in support, right? Ideally, service ping or another bulk data export mechanism would support more granular data, so we can have like this kind of setup, but more granularly. And for data analysis and visualization, it's interesting to think what we can learn from like these summary statistics about projects, right? How meaningful is the pipeline success percentage, and what other data can we relate to find optimization potential? So like compute minutes per pipeline, right? Like pipeline would give us pipeline runtime fundamentally, and failed pipeline count per default branch, right? How green is our master? So these are all pretty interesting to think about and give lots of potential for further exploration. Thank you very much.